Okay, Red Elk runs with a purely horizontal velocity of 4.3 meters per second and lands 5.1 meters from the base of the cliff. So let's draw a picture of this. Okay, that's interesting. Okay. Okay, so he's going this way at 4.3 meters per second, and he lands here 5.10 meters. Not enough information is given to solve this problem. Okay, let's look. Okay, now remember, in all projectile motion problems, you know these two things. They'll be the same for the planet Earth, right? Because it's a cliff problem, because it's purely horizontal, we know this guy. Right, so you just always know these for this whole Quizlet, right? Okay, let's see what this is. Okay, so we also know this, and this, and we know this. Okay? So pause for a moment here. Just see if you can fill that in, okay? All right, so the things we always know, that's 0, negative 9.8, and this is 0, right? So purely horizontal velocity is we're not moving up or down. Nothing to propel us in the horizontal direction, and gravity is accelerating down. And then this 4.3 is our velocity horizontally, right? And then 5.1 is how far it is from the base of the cliff. So that's our 5.10. That's a 5.10 clearly, right? All right. Okay, so let's look at, I can do nothing, by the way, in the vertical direction. I only know two things, right? But I can do something in the horizontal direction. So let's do horizontal, right? Okay, remember that v is just x over t. So therefore t is x over v. So the time is 5.10 divided by 4.3. And that comes out even, actually. 4.1 divided by... comes out even to 1.186046512, approximately 1.186. That's good enough seconds, right? Okay, so now we know this time, 1.186, 1.186. That, by the way, sews up the whole horizontal side here. And also we can do stuff with this vertical side here, right? So now in the vertical direction, okay, in the vertical direction, now we can find, let's go x is VIT plus 1/2 AT squared. The initial velocity is 0, so this becomes 1/2 negative 9.8 times this time, right? So 1.186 squared. Now I'm using the whole number on my calculator. I'm not rounding, so I'm going to go 0.5 times negative 9.8 times. I'm just grabbing that answer and squaring it. If you're rounding it to this, then you'll be slightly off. I get negative 6.892. So x is equal to 9286. And this is, I didn't round this time. That's why I'm getting that. If you're in the ballpark and you rounded, you're probably good too. All right, so this is negative 6.89. I'll say 3 meters because I'd round that to a 3. All right, let's find the final velocity. So final velocity is initial plus acceleration times time, right? So it's going to be 0 plus negative 9.8 times 1.186. Okay, so negative 9.8 times, and then I'm just using the up arrow on my calculator to put that whole number in there. I'm getting negative 11.623. All right. All right, so let's see what questions it asks for 4. What time is he in the air? A. Right? Well, this is our time, right? 1.19 seconds, roughly. I'm just rounding to 3 sig figs, right? Do we get that right? Ooh, let's see. 1.86 seconds. Oh, that's funny. Oh, 1.186. Okay, yeah, we got it right. Okay, and then B says, I was like, I got it wrong. That's bad at this point if you get it wrong. Okay. B says, how high is the cliff? Well, this is our vertical displacement. To get from the top to the bottom, we went down 6.89 meters. So I'm going to say that the cliff is 6.89 meters tall. Okay. Did I get that right? Oh, yeah, I sure did. All right, then C says, what was his final vertical velocity? Well, this is it right here. Okay. So that was our B. Our C is going to be, I'm going to say negative 11.6 meters per second. Right, don't forget the minus sign. It's going down, right? All right, let's see. And then D says, draw a picture of its final velocity of impact, calculate the speed he's traveling, find the angle below horizontal that it makes. All right, I'm going to erase in 3, 2, 1. All right, there we go. So he's going 4.3 to the side. And then when he hits the ground, he's going 11.623 down. So this is 4.3 meters per second. And then he's going negative 11.623 meters per second. So the velocity is this guy, right? Okay, that angle is inverse tan of 11.623 divided by 4.3. So it's always the opposite over the adjacent, right? Okay, so that guy divided by 4.3, second tan, second answer. I'm being lazy here. 69.7 degrees. Did we get it right? Oh, yeah, we're good. Okay, but we still have to figure out the magnitude of the angle, okay? Okay, so this is the speed of it, is the magnitude, right? So 4.3 squared plus 11.623 squared. Then hold on. I'm actually going to use that 11 thing with square that. I had to put it in parentheses. I'm getting 12.4 meters per second. All right, so here's how you're going to show me, here's how you're going to get all the points, okay? First off, you're going to draw the picture correctly. So the x component is an arrow. The y component is also an arrow. Okay, the vector itself is this. It's the thing that goes down like that. That's actually the vector right here. Okay, that thing is an arrow. It's going down and to the right, or down and to the left, doesn't really matter, right? Okay, you've labeled it with how much it is. You figure out how much it is. You've labeled which angle you found. You labeled the angle what it is. Okay? You can even say equals if you want to. Okay? Good enough.